So it's not uncommon for us to load analytics libraries along with our Angular applications. And those analytics libraries track user interactions. So you can see here as I click around in the application, I'm getting this track event being fired. Now, analytics libraries like this are typically loaded asynchronously in a non-blocking fashion, which means that they don't directly impact the load of the main request. However, anecdotally, I can tell you that loading analytics libraries, even asynchronously, has a negative impact on the TTFI, or the time to first interaction for your user. So as a thought experiment, I wanted to see if I could create a proxy to these analytics libraries that allows analytic events to be fired immediately in an application, but in a way that defers the loading and processing overhead of the underlying analytics library. And to see this in action, if I refresh here, you can see that I can click around and we're not getting any logging because the underlying library isn't available. But if we wait a few seconds, the library will load and all these events will get flushed to the console. There we go. So how does this work? Let's jump into our app component. So our app component is injecting this analytics service. This analytics service is the proxy in this thought experiment. And you can see that as I click around, I'm calling events on that proxy that look like I'm calling methods on that proxy that look like methods on the underlying library, only these are strongly typed, right? So I'm calling track, I can call identify. Now, this analytics service is going to be queuing up events internally and then flushing them to the analytics library once it's loaded. Now that sounds complicated, but by using promises under the hood, we basically get that behavior for free. So let's look at the analytics service. Internally, it's going to use a script loader, which we'll talk about in a second. But if we look at the identify and track methods, which is what our app component was calling, you can see that both of these are using this run method, which is accepting a callback. That callback, when it's invoked, is going to provide that underlying analytics library. So essentially, we're using this run method to queue up these calls to the underlying analytics library. And how does the queuing work? Well, if we look at the run method, it takes the callback, and what we then do is call this getScript method, which is right here. Now this getScript method is going to return a promise. So when we say .then on this promise and then pass in the callback, which resolves to our analytics library, what we're going to be doing implicitly is queuing up these callbacks. Because when you call .then on a promise, what you're doing is essentially queuing up the callbacks that get invoked once a promise is resolved. So while it sounds complicated to queue things up in memory, because this workflow uses a promise, we're essentially getting all of that behavior 100% for free. Now, what is getScript? getScript under the hood is using this script loader to load the analytics library asynchronously at some point in the future. And this script loader here is the instance of delayed script loader. Now, delayed script loader takes the URL to the underlying analytics library and a delay. In this case, we're going to be using 10 seconds. So essentially, when we say await here, this .load method is going to sit and block internally to the promise for at least 10 seconds before it resolves, at which point we know that our analytics library will now be part of the global scope, or the window object in this particular case. So let's take a quick look at how the delayed script loader works. The delayed script loader takes a URL or set of URLs and the delay, and it is also going to be using a promise under the hood. So let's look at the load method, which again is what we're calling here inside of our getScript promise. This load method returns the existing script promise if it exists. So essentially, the first request to .load is going to set up this script promise, then any subsequent request is going to just return the existing promise. And again, that's how we get that implicit queuing up of requests in memory on the same promise, such that all those requests get invoked once this single script promise gets resolved. So the first request that didn't have the script promise available to it is going to set it up, and it's going to do that by initializing a first promise that fires when the delay gets passed. So essentially, this is going to now wait for 10 seconds before this promise gets resolved, at which point this internal callback gets involved. where we map URLs onto a promise, load script, which will create a script element and inject it into the head and then bind to the onLoad event handler. And then once all of the URLs get loaded into the page, we resolve that promise, which resolves this line here, which is when we have that analytics library in the global context. You can pick through this a bit more, but essentially all it's doing is creating that script tag, binding the resolve and reject to the onLoad and onError of that script tag, and then injecting that script tag into the head of the document. Right? So it's doing that, though, at some milliseconds in the future. So just to quickly recap, we have our app component. The app component injects at runtime, at bootstrap time, the analytics service, our proxy class. That proxy class exposes analytics methods that look and act like the analytics methods in the underlying library. However, the underlying library isn't actually available until some point in the future when the script loader has loaded it after a 10-second delay, at which point all of the callbacks that were queued up waiting for that promise to resolve are invoked, which are, again, these callbacks that have been queued up here, which now expose the underlying analytics library, and then we can essentially pass through those methods to the underlying analytics library. So again, what this is doing is, if we jump over to the network activity, what we can see as I refresh that there's no analytics library here. In fact, if I clear this and we wait and see, this should come through in a few seconds. Boom, there's our analytics service. That's the underlying analytics library, at which point all of our tracking requests that were queued up in memory are now flushed. So essentially what this does is allow us to start tracking analytics events at bootstrap time, but not incur the loading and parsing of this JavaScript file until some point in the future, which I theorize, would have a benefit to the time to first interaction for your application.